Good evening, everybody. I'm Jag Thind. I'm a senior data engineer at Bonga.com. No booze, please. And what I want to talk about tonight is database deployments. And if they're slow, then don't deploy them. But it sounds like an obvious thing to do. But as you'll see, it was quite challenging in the environment I work in. And it was simply based around the premise of only deploying a database when something actually changes. So this is the environment that I work in. All the databases are part of a server architecture, so where more or less every service has its own database. I'm not saying that's the right thing to do or it's a bad thing to do, but from a data platform perspective, it does pose some challenges. These are the type of technologies that you use on a day-to-day. At the heart, there's SQL Server data tools and SQL Server. Most of the data platform is built on SQL Server. And around it, we use Git and Gerrit to manage the code, Jenkins for all the CI, and PowerShell and MS Build to write all the scripts, build and deploy scripts, and NuGet and Artifactory for package management. Anybody using Artifactory out there? Good, bad? Yeah? I thought it was quite good, actually. Okay. So the environment that I'm from, this is the type of challenges that it poses. The last time I checked in across all our CI environments and production. There are more than just over 1,000 databases, all deployed to in a continuous integration environment. We've got developers around the world, over 5 countries, and there's more than 100 developers. So the team that I'm from realized that we couldn't make all the database changes for them. We had to enable them to make the changes themselves, but do it in a way which is to a standard that we told them to do things at. So it produced some challenges, but I think, and this is one of the reasons why the databases were deploying quite slowly, and the solution that were introduced was a very simple solution, but kind of just allowed them to get over the barrier of slow database deployments. The desired state that we wanted was Jenkins or TeamCity or Go or whatever, Concore CI, whatever CI tool you want to use, but all the databases are deployed in a uniform, consistent standard across all our regions, across all our products, and we don't basically have to do anything. But they would do exactly how we would configure the pipelines to do. And we realized that if the developers were happy and not using the database as an excuse for not releasing changes, then the company would be happy, they'll be getting return on investment, and everyone would be good. But what we realized was the databases were actually a bottleneck to deployment, and developers were more or less waiting around for quite a while when they were releasing code, and it made the databases become a bottleneck for them releasing the code to production. And so what this meant was that you can see as part of any code change, there's database change, there's configuration. But if we broke down the pipeline, we could see that the database part was actually taking the longest. So not a good place to be. So I had a look at what was actually going on. And in the middle, so I'll start from the middle. What we found was that the databases were actually deploying when nothing had actually changed. So you'll see from the left-hand side, these were some of the causes of why databases were deploying when nothing had actually changed. We had repos which had 30, 40 services in them, which again has 30 or 40 databases in them. So if anybody changed one bit of code, database or not, it would just trigger a database build and deploy across all 30 or 40 databases. And this would mean that people were waiting around for the databases to finish deploying, which inherently are slow. We had databases which were referring to common database projects. So the data engineering team took the wise step to introduce standards to all the developers of how databases should be set up, that every database should have a particular structure in terms of where data should be laid out, not what the tables and things should look like, but like default file groups, where indexes should be placed, just some common standards which we thought were really important. So whenever anything in that project changed, or the repo which that project was in changed, it caused a cascade down for all databases to be rebuilt and redeployed. We had rudimentary database build and deploy scripts, which when they were introduced 4 years ago, they seemed like a good idea, and they did the job for a couple of years. But when we got to this stage, we really found they weren't really that clever, and they could be improved with the solution that I'm going to show you. And on the right, this is some of the things that were the result of databases deploying when nothing had actually changed. Build agents were busy all the time, just building and deploying databases when they weren't actually doing, nothing had changed, which meant that developers couldn't release their code on time. We had a very busy CI system on the surface, but really it wasn't really doing much. Network and storage overutilization. We had packages and artifacts being pushed around all the build agents, and that kind of added to the stress of the network and to the SAN. The databases were backed up by a SAN, so that when they were being deployed to, when there were changes were happening there, it would just cause performance problems on the SAN. So it wasn't a very good place to be. And then we had downstream pipelines and jobs which were triggered when any one of those databases which had changed was deployed. Because what we had built was a reporting platform of all the front-end databases, and whenever any of those front-end databases changed or looked like it changed, it would trigger the downstream pipelines and jobs to trigger. So the solution that we came up with was a very simple solution, but it's more or less done the job. So before I move on to the solution, we had a look at all these causes which were causing this thing in the middle, and we realized that big repos containing many database projects couldn't be split up into smaller repos quite easily. It was a hard thing for teams to do. They couldn't do it quickly, so we had to introduce something which would allow them to get to a place where we only deploy databases when they change without them having to do all the work, them being the developers. What we had was using ThoughtWorks Go. Has anybody using ThoughtWorks Go? All right, so honestly, what do you think of it? Yeah, it sounds like it's not so good. Yeah, we stopped as well. We were using ThoughtWorks Go across all our CI, and I would say if anybody's thinking of it, it was a very challenging thing to do because it has pipelines which are made up of stages and jobs. And when you deploy it to an environment, you have a pipeline which can have many upstream pipelines. So if any of those upstream pipelines changes, it causes the whole pipeline, the deploy pipeline, to execute. But within that pipeline, you have jobs, and those jobs do not know if they should be actually deploying something or not. In the case of databases, they were all deploying one by one or in parallel. I think you can do them in parallel as well. But it just meant that we couldn't split up having upstream pipeline and a job like you have with Jenkins. So that was probably one of the main causes of this whole slowdown. So the solution was very simple, actually. All we had to do was introduce some detection around the deploy scripts to say if they answer the question if it should deploy or if it should not deploy. And all it meant was these three simple steps. When the database builds, we produce a timestamp file which we put into the output of the build, which is simply a text file which has a timestamp in it. And when it deploys, we wrote some PowerShell logic which looks at that timestamp file and compares it against to the previous one. In our case, that was on the build or deploy server. So let me start again. Second step was we deployed the database and we copied the timestamp file to the target server. And the next time we did a deploy, we checked the timestamp file that we already had from the build and compared it to the one that was already on the target server. And if it was the one in the build was greater than the one in the deploy, then that meant the deploy should happen. If it wasn't greater, then nothing would happen. This meant that every time the ThoughtWorks Go pipeline would execute hundreds of jobs, they all might be running in parallel, but some of them might not actually be doing anything because of this condition. And that was more or less it. That was a solution to all our database problems with regard to deployments. There are cleverer ways to do this, but this is a very simple solution without actually meaning the developers had to restructure all their code and split up all their repos into smaller repos, which is the right thing to do. But in our case, we just didn't have that luxury. So that was it.